Good morning, everyone. In the last lecture, we talked about what is the meaning of nano, what is the difference between nanoscience, nanotechnology, right? Now, the topic is length scale and importance of nanoscale. Nanotechnology is the process of miniaturization from micrometer scale, that is 10 raised to power minus 6 meter, to nanometer scale, that is 10 raised to power minus 9 meter. 1 nanometer is equivalent to 5 silicon atoms or 10 hydrogen atoms placed in a line. When one goes down from bulk size to micrometer scale, physical properties of materials remain same. However, in nanometer scale, the physical properties of material changes drastically. ये हमने लास्ट टाइम भी बात की थी कि जब हम बल्क साइज से रिड्यूस करते हैं माइक्रोमीटर तक जाएंगे तब तक भी आपको प्रॉपर्टीज में चेंज नहीं मिलेगा. But when we goes to the nanometer scale, there will be drastic change in the properties. Okay. Bulk material से micrometer यानी कि 10 raised to power minus 6 की range, properties will remain same. In the range of 10 raised to power minus 9 meter, that is nanometer scale, physical properties will change drastically. Okay. अब इसलिए जो नैनो स्केल की हम बात कर रहे हैं, क्या इंपॉर्टेंस है इसकी? तो फर्स्ट वन इज क्रिस्टल इन नैनोमीटर स्केल हैव वेरी लो मेल्टिंग पॉइंट. Crystals in nanometer scale have reduced lattice constants. Ferroelectrics and ferromagnetics may lose their ferroelectricity and ferromagnetism in the nanometer scale. Bulk semiconductors changes to insulators in the nanometer scale. Reactivity of bulk material is different from the reactivity of same material reduced to nanoscale. कितने चेंजेस आ रहे हैं आप देखो, मेल्टिंग पॉइंट चेंज हो रहा है, लैटिस कांस्टेंट चेंज हो रहा है, फेरोइलेक्ट्रिक फेरोमैग्नेटिक प्रॉपर्टी उनकी चेंज हो रही है. सेमीकंडक्टर जो बल्क सेमीकंडक्टर वो इंसुलेटर में चेंज हो जाता है जब हम उनको नैनोमीटर स्केल में लेकर आ जाते हैं. रिएक्टिविटी चेंज हो रही है नैनो स्केल रेंज में. ओके, नाउ क्लासिफिकेशन ऑफ नैनो मटेरियल. This classification is based on the number of dimensions of a material which are outside the nanoscale, that is less than 100 nanometer range. Accordingly, zero-dimensional जो nanomaterial है, in which all the dimensions are measured within the nanoscale, no dimensions are larger than 100 nanometer. Most commonly, zero-dimensional nanomaterials are nanoparticles. एक हमने क्लासिफिकेशन किया जीरो डायमेंशनल, एक हमने बताया वन डायमेंशनल और एक हम बता रहे हैं टू डायमेंशनल एंड 3 डायमेंशनल. जीरो डायमेंशनल में सारी डायमेंशन जो है विद इन द नैनोस्केल रेंज में होगी. कोई भी डायमेंशन आपकी 100 नैनोमीटर से बड़ी नहीं होगी. इन वन डायमेंशन इज आउटसाइड द नैनोस्केल. दिस क्लास इंक्लूड्स नैनो ट्यूब, नैनो रॉड, नैनो वायर. टू डायमेंशनल में टू डायमेंशंस आर आउटसाइड द नैनोस्केल. This class exhibits plate-like shapes and includes graphene, nanofilms, nanolayers, and nanocoating. Three-dimensional में सारी जो all that are not confined to the nanoscale in any dimension. This class can contain bulk powder, dispersion of nanoparticle, bundle of nanowires, nanotubes, as well as multi-nanolayers. Okay, ये हमारा nanoscale का dimension. Zero dimension, all dimension जो है nanoscale की range की है. वन डायमेंशन, टू डायमेंशन एट द नैनो स्केल, वन डायमेंशन एट द मैक्रो स्केल में है. टू डायमेंशन में टू डायमेंशन जो होगी वो मैक्रो स्केल में होगी और एक नैनो स्केल में. थ्री डायमेंशन में ऑल डायमेंशन जो होगी वो मैक्रो स्केल में होगी, नो डायमेंशन एट द नैनो स्केल. ओके, ये जीरो डायमेंशन के एग्जांपल क्लस्टर्स, नैनो ट्यूब फाइबर रॉड वन डायमेंशन में, फिल्म्स एंड कोट्स टू डायमेंशन, ये प्लेट लाइक स्ट्रक्चर होगा. पॉलीक्रिस्टल जो है वो 3 डायमेंशनल में आते हैं. ठीक है, ऑल द डायमेंशन आर ए मैक्रो स्केल रेंज. Okay. Now there are different type of nanoparticles. Nanoparticles can be classified into different types according to the size, morphology, physical and chemical properties. Some of them are carbon-based nanoparticles, ceramic nanoparticles, metal nanoparticles, semiconductor nanoparticles, polymeric nanoparticles, and lipid-based nanoparticles. Okay. एक क्लासिफिकेशन तो हमने देखा बाय द डायमेंशन, जीरो डायमेंशन, 1D, 2D एंड 3D. ठीक है, यहाँ पे हम देख रहे हैं फिजिकल केमिकल प्रॉपर्टीज के बेस पर, उनके साइज के बेस पर, मॉर्फोलॉजी के बेस पर, दे कैन बी ऑफ डिफरेंट टाइप. तो फर्स्ट आता है हमारा कार्बन बेस्ड नैनो पार्टिकल. कार्बन बेस्ड नैनो पार्टिकल्स इंक्लूड टू मेन मटेरियल्स, कार्बन नैनो ट्यूब्स जिनको हम बोलते हैं CNT, एंड फ्लोरेंस. CNTs आर नथिंग बट ग्राफीन शीट्स रोल्ड इनटू अ ट्यूब. सीएनटीज क्या होते हैं? ग्राफीन शीट्स ही होती है जिनको आप ट्यूब में रोल करते हो. These materials are mainly used for the structural reinforcement as they are 100 times stronger than steel. CNTs can be classified into single-walled carbon nanotubes and multi-walled carbon nanotubes. CNTs are unique in a way as they are thermally conductive along the length and non-conductive across the tube. Fullerenes are the allotropes of carbon, having a structure of hollow cage of 60 or more carbon atoms. These have commercial applications due to their electrical conductivity, structure, high strength, and electron affinity. फिर आता है हमारा ceramic nanoparticles. These are inorganic solids made up of oxides, carbides, carbonates, and phosphates. These nanoparticles have high heat resistance and chemical inertness. They have applications in photocatalysis, photodegradation of dyes, drug delivery, and imaging. By controlling some of the characteristics of ceramic nanoparticles like size, surface area, porosity, surface to volume ratio, etc., they perform as a good drug delivery agent. These nanoparticles have been used effectively as a drug delivery system for a number of diseases like bacterial infections, glaucoma, cancer, etc. Then after, metal nanoparticles. Metal nanoparticles are prepared from metal precursors. These nanoparticles can be synthesized by chemical, electrochemical, or photochemical methods. In chemical methods, the metal nanoparticles are obtained by reducing the metal ion precursors in solution by chemical reducing agents. These have the ability to absorb small molecules and have high surface energy. Then after comes metal nanoparticles have applications in research areas, detection and imaging of biomolecules, and in environmental and bioanalytical applications. For example, gold nanoparticles are used to coat the sample before analyzing in SAM. This is usually done to enhance the electronic spin, which help us to get the high quality SAM images. Scanning electron microscope में जो है हम मेटल के नैनो पार्टिकल्स है वो यूज में लेते हैं, ठीक है, जो एनालाइज करने के काम में आता है पार्टिकल्स को. Semiconductor nanoparticles have properties like those of metals and non-metals. They are found in periodic table in groups second to sixth, third to fifth, fourth to sixth. These particles have wide band gaps, which on tuning show different properties. They are used in photocatalysis, electronic devices, photo optics, and water splitting applications. Some examples of semiconductor nanoparticles are gallium nitride, gallium phosphide, indium arsenide. Okay, so these are the examples of semiconductor nanoparticles. फिर आता है हमारा polymeric nanoparticles. Polymeric nanoparticles are organic-based nanoparticles depending upon the method of preparation. These have structures shaped like nanocapsule or nanospheres. A nanosphere particle has a matrix-like structure, whereas the nanocapsular particle has core shell morphology. In the former, the active compounds and the polymer are uniformly dispersed, whereas in the latter, the active compounds are confined and surrounded by a polymer shell. Some of the merits of polymeric nanoparticles are controlled release, protection of drug molecules, ability to combine therapy and imaging, specific targeting, and many more. They have applications in drug delivery and diagnostics. The drug deliveries with polymeric nanoparticles are highly biodegradable and biocompatible. Then after comes lipid-based nanoparticles. Lipid nanoparticles are generally spherical in shape with a diameter ranging from 10 to 100 nanometer. It consists of a solid core made of lipid and a matrix containing soluble lipophilic molecules. The external core of these nanoparticles is stabilized by surfactants and emulsifiers. These nanoparticles have applications in the biomedical field as a drug carrier and delivery and RNA release in cancer therapy. Thus, the field of nanotechnology is far from being saturated, and it is at the statistic stage, sitting on the staircase of an exponential growth pattern. It is basically at the same stage as the information technology was in the 1960s and biotechnology in the year of 1980. Thus, it can be easily predicted that this field would witness the same exponential growth as the other two technological fields witnessed earlier. Okay. So ये तो हमने टाइप्स देखे नैनो पार्टिकल्स का क्लासिफिकेशन देखा बेस्ड ऑन देयर डायमेंशन बेस्ड ऑन देयर प्रॉपर्टीज दे कैन बी मेटालिक दे कैन बी सेमीकंडक्टर हमने नैनो पार्टिकल देखे लिपिड नैनो पार्टिकल देखे राइट अब ये अब जो हमने बताया कि जिस तरीके से इंफॉर्मेशन टेक्नोलॉजी बायोटेक्नोलॉजी की जो एक्सपोनेंशियल ग्रोथ हुई है नैनो टेक्नोलॉजी जो है उसी लाइन में ओके So thank you everyone.